All right, cool. Yeah, okay. Well, this will be the Scooby-Doo summary then. Ruh-roh. Um, all right. So let's see. First of all, let's talk about service learning projects. So, your SLP presentations are on Monday, so 6 days from now. And that's also the day that your SLP proposed final report is due. So let me um, show you an example from a few years ago of a SLP final report, just to kind of illustrate that this is different from a one-page homework submission where you might, say topic colon and then write a sentence about the topic, objective colon and write a sentence about the objective. This should be a self-contained report that basically describes your entire project, okay, which to some degree you've hopefully been working on since the beginning of winter quarter, so January, right? So several months worth of effort reflected in this report. And keep in mind, several months of effort, not necessarily several months of forward progress. But, since in winter we started with the original proposal, you may have, said, okay, I'm going to do such and such, and then started researching it and discovered, I don't think I can do such and such in the time period, or I don't think I'm really interested in this, I'd rather do something different. And so some people have changed projects along the way. All of that can be part of your final presentation, right? Your final report. That's part of what the goal of this SLP is picking a topic and assessing it and doing a feasibility and making adjustments and so on and so forth. So this report should document what you've been doing since January, even if you don't feel like since January you've been moving closer and closer to your goal. Put it all in there. So this is just an example report. This was a student who was working with a novel machine learning system to try to teach it to drive a car in a video game, and he wired up a 2000 plus node GPU and ported this machine learning system to that platform and then tried to use that to do rapid evolution of algorithms. So, title page, abstract, background information. So this section is talking about the machine learning system, something called exist. Pseudocode outline of what is being done here. Comparison to other learning systems that have been used on video games, and the pros and cons compared to this solution. Some data, overview of the process, right? Details about the car that's being driven, right? The aspects of it. Different development environments that were being used. Ended up using Unreal, right? So information about that, setting up the project. Some screenshots about how this was integrated into the game. Links to things like Google Drives that have information about the gameplay. Source code, right? Code for different parts of the systems. Links to GitLab that let you get to the source code through a GitHub repo, and so on and so forth, right? And the results at the end of this, the car did learn somewhat to drive down the track, but not nearly as good as a 6-year-old would be able to do after a few minutes of playing the game. But that wasn't the point of this. This was an exploration of something that hadn't been explored before. Pseudocode for the machine learning algorithm, right? How did you install the necessary parts on your system? All of this stuff that you have to do can be part of your report. You got to go out and buy a new computer because the one you were using didn't work well, or you had to change from using Unreal to using Unity because the learning curve on Unreal was too steep, or it didn't support the language that I knew how to use. or to learn how to program this, I had to first learn some C++, and so I had to take some classes, right? And you can put all of that in here, right? So whatever you've been doing, right, goes in here. And so that's just an example, but you know, it's certainly more than 1 or 2 pages with a couple of sentences describing each section. Enhancements, right? Future work, things you would do in the future, and so on. Conclusion: Exist won't be controlling real cars anytime soon. So, you know, the outcome of this was, you know, in some sense, well, you know, I wanted to make a machine learning system that would learn to drive this car, and it didn't actually work very well. But, you know, lots of stuff. Yes. Yeah, and if you like waiting for shaders, it's your thing. Um, is it always going to be past tense? Yeah, it can be past tense, future tense. That's all fine. All right, so just something to keep in mind. So final report has to be submitted on Canvas as a PDF file by 8 a.m. Monday. Okay, that's a rigid deadline. So if you email it to me 2 hours later, I'll accept it and I'll look at it, but you don't get a grade for it. Okay, because I'll start grading those. So 8 a.m. Monday. Okay, next thing is the presentations. So in winter quarter, this class came immediately after the previous section. So section A was 10 to 11, this class was 11 to 12. So we did a 2-hour presentation, and students came during whatever time their class was. In this quarter, Izad's class is, you know, 10 o'clock in the morning. Section A is 10 in the morning. This section is, you know, 2 in the afternoon, so there's a gap there. So you have a choice, okay? You have 2 options. Option 1, 10 a.m. to 11 a.m. Monday. And I believe that's June 7th. And that's going to be a presentation just like what it was in winter quarter. So it's going to be a series of breakout rooms. You'll have a pre-assigned breakout room. You go in there, you take turns with the other people in the room, do your pitch, and visitors will come by and visit rooms and come in and listen to you and ask you questions and hopefully offer you millions of dollars to come work for them and develop your idea. So that's option 1, okay, and that'll look very much like what happened in winter. The trick here being it's going to be at 10 a.m., right? And some of you may have classes or other obligations at 10 a.m. Option 2 is 2 p.m. to 3 p.m. that same day, which is regular class time. And so here you'll be presenting just to the class. So we'll let you share screen and we'll just go around and everybody will present. Okay, those are your only 2 options though, and those have to happen on Monday. So you need to plan on being in class Monday at 2 o'clock to present to the class, or coming at 10 in the morning to the general presentation combined with these odd students. All right, and so what I need right now is I need you to, does everybody know how to raise their hand? If you don't know how to raise your hand, let me know in chat. Okay, so I'm going to ask you, if you want to do option 1, raise your hand in Zoom and keep it up. If you don't know how to raise your hand, send a message in chat. But if you can raise your hand, please just raise your hand, because otherwise I gotta sort through. Or raise your hand in real life. All right, and I'm gonna ask you to keep your hands up, and we'll wait till everybody's done, and then I'll go ahead and take a screenshot. So you're raising your hand if you're committing to come to the 10 a.m. Presentation. And that means I'll go ahead and put you on the schedule for that, assign you a room, and you'll want to show up for that. How likely are you to be able to come to 2? If you can commit to 2, I'd rather have you go ahead and commit for 2.
Unfortunately, the project board thing, it just comes up like randomly. But
Okay.
the chances of me having prod at both 10 and 2 is highly unlikely.
All right, let's go ahead and put you down for 10 then. And then if you
Okay.
don't make it at 10, hopefully you can make it at 2.
Oh, okay, thanks.
All right, but everybody else, if you got your hand up, I'd want you to come there at 10. All right, so it looks like we have 3 people plus a maybe for 10 o'clock. All right, so let me write those down. And all right, awesome. You can put your hands down, or you can keep them up if you like to stretch. Cool. So everybody else, we will do presentations Monday during class time, and but same drill as in spring. We'll basically just screen share and you'll present as in winter. Just share your presentation with the class, and so a few minutes of talk up to however long you feel you need to go through your project. All right, but regardless of which presentation you're doing, reports are due at 8 a.m. Monday. All right, good, awesome. So any questions, concerns about any of that?
So then I
Self-driving Mario Kart with recurrent neural network, awesomeness. All right, so let's play with client server stuff. So that's uploading. Now this is not necessarily something that will map directly to PA5, but let's make an example of a client server pair. And I did this once this morning, so let's use a different example this time. This morning, what I did was made a pair of processes, and each one created a pair of threads, which were called to and from. And were set up so that the server would write into the to thread would write into a socket, and the client's from thread would read from the socket and display. And the client would, read the keyboard, write it into the to socket, and the server's from thread would read from that socket and display to the output. So we had two-way communication going back, full duplex. So the server could be typing, the client could send a message, the message would come out immediately because we weren't blocking inside here waiting to read from the socket, right? We had a separate thread for reading from the socket and a thread for writing to the socket. And this is always waiting for the user to hit enter. This is waiting for the other end of the connection to hit enter and send something through. So we broke that into a pair of processes. So let's do a different example for the afternoon, and then if you want, you can go back and look at the morning lecture for a second example, and the morning class can do the same. So let's make a square root server. And so this is going to be a server process that hangs out and runs and lets people lets people connect to it and calculate square roots. But we're going to set it up in such a way that we can have multiple versions of this server running, each in their own thread, so we can have multiple clients talking to it. Let's see, if you're connected to more than one client, can you just use a single thread pair? You need one per client. In what instance? Like for this example? For PA5, so you're only required to have one client, but if you were to set it up for multiple, so you're doing multiplayer, right? If you keep everything in sync, I think you still only need one thread, because theoretically you know which socket to read from. It's probably easiest to do a separate thread for each client. You can do it with a single one, but it's probably easiest to have each one in its own thread, and then each thread could say, you know, wait, you know, read a XY pair from the socket and pretend it's a mouse click. And in practice, that's going to be pretty straightforward to put together, but in reality, you know, those should come in a fixed order over and over and over again, as long as all the code is well behaved, and so you're not going to end up blocking. But yeah, put them each in a thread. That's going to be easiest. Is there a way to tell who the data is coming from? So you could have each client identify themselves. And you could give them you can read the IP address and the port number that the information is coming from. But when you read from a socket, right, presumably you know who that socket belongs to. Right, so you make a scanner off of the socket's get input stream, and when you read from that scanner, you're reading from the corresponding socket. Let's see, how long should we aim to present for? You know, 6 months worth of work. You should have a few minutes worth of presentation. I don't know, 10 minutes is probably a pretty good nominal length. If you feel like you've only got 60 seconds worth of stuff to say, maybe step back and think larger scope. You know, maybe I'm just talking about the results, and I could also be talking about the process. Or maybe I could also talk about the motivation of why I chose this project, right? So see if there's more that you can add in to give more of a full big picture view of your project, and that'll usually bring you out. If you have more to say than that, you know, that's sometimes an easier task to pare it down, but 10 minutes, not a bad length. Go over how to download and compile our PA5. So if you're writing in Eclipse, there's your workspace / source. That's where your Java files should live. So just copy them from there into an empty directory, and then go in that directory and just java c star.java should compile everything. And then Java, I forget what I told you to call the main class, but if it's something like net dot, I don't know what I told you to call it, but just Java, the name of that class, and that should go ahead and run it. Cool, you're welcome. All right, so let's play with threads and sockets. So here's the setup. We're going to make a server. And it's going to listen on a port, and I'll just stick with port 1234. Let's see, on Eclipse I haven't got beyond the requirements for a couple of jar files. If they're the same jar files as before, I can figure out how to make that work. But that's usually using a different layout manager or some other kind of widget. But I can probably figure out how to make that work. If you can include those jar files in your Git repo, that would be helpful. Alright, so we're going to have client 1, and client 1 is going to talk to port 1234. And when we accept the connection, we're going to get a new socket. What we're going to do at that point is we're going to create a new thread. And that new thread is going to communicate with this client. And then client 2 is going to come along, talk to port 1234. And when this accepts that connection, it's going to create a new thread. And that thread will have a socket which communicates with this client, and so on. So we're going to have a server whose main job is just to accept connections and create threads. And each thread that's created will be the actual square root server that we can send a number and it'll send back the square root. And we'll send another number, it'll send back the square root. Alright. Nothing really directly to do with PA5, just an example of passing off the networked operations to a thread. And so to the degree that that's reminiscent of PA5. Alright, so we'll make a square root directory. Alright, so what are we going to do in here? We are going to create a server socket. So we'll try to construct a server socket. Alright, now we have a server socket. We're going to wait for connections. So I'm going to do this in a forever loop. Okay, so I'm going to say while true. Yeah, let me do this. I think it's going to want that to go inside a try catch. So I'm going to accept a connection, and when I accept, right, I'm going to get a socket which is connected to this client socket, and I'm going to feed that off into a thread. Let's see. So you can only have one socket at a time. Right, I can only have one listener at a time. Yes, but, so that's why we're going to break this off into a separate thread. So I have one server socket on port 1234 here, and when I accept, I get back a socket which will have, you know, some random port number associated to it. That's the thing over which I can communicate with the client, or whoever connected to me. And so I'm going to farm off a new thread at this point to, you know, do what it's supposed to do with this socket, and I'm going to come right back up here and accept another connection. So let's go ahead and print something. So I'll accept a connection, I'll do that. I'll go ahead and construct a new thread, and I'll pass that socket information to it. And I'll go ahead and start. So when we accept a connection, right? So the client talks to port 1234, that's the server socket. When we accept that connection, a new socket is created with a different port number. That's the socket that's connected to the client. So this will be port, 55423 or something like that. That gets connected to the client socket. So we're not actually communicating with the client on port 1234. That's how the client says, hey, make a socket so you can talk to me. And we get this new socket. And 1234 is still hanging out there available for more connections. All right, so we will we'll go ahead and create a thread. We'll pass the socket to the constructor, and then we'll say go ahead and start. Remember, start will make a new thread and execute the run method of this object, MT in this case, inside that new thread. So let's make my thread. Alright, so this is a socket through which we communicate with the server. And we'll save that in the constructor. And then this code that we're about to write gets executed when we call start, but it gets executed in a new thread. Alright, so what should our main thread be doing? Well, it should be reading from the client. It should read a real number, it should calculate the square root, and then it should return that square root. Alright, so let's while we're up here, when we've got the socket, let's go ahead and I won't get too super duper fancy. Let's just go ahead. And build all of this in the run method. I could build the scanner and the print writer inside the constructor, but I'm just going to do it in here. So let's put all this in the try-catch block. Alright, and really lowballing the error checking on here. So we'll create the scanner and the print writer using the input stream, output stream of the socket. So we'll read a number and we'll write out its square root. So we'll do while scanner has next double. So we'll call scanner.nextDouble, which will give us the next double precision number available on the input. We'll pass that to math.squareRoot, and we'll pass that to the print writer's print line method. And we'll do a flush to force that output. And we'll do that until there's no more doubles available, and then we'll go ahead and we'll close the scanner. And that's the end of our run method. And that's the end of our class. All right, got the idea? So this is a server process. This will run and it will sit in an infinite loop. It creates one server socket, port 1234. It sits here in this infinite loop, gets a connection, creates a thread with the socket that is connected to the client, starts the thread, goes back, waits for another connection, gets a connection, creates another thread, goes ahead and runs that. And let's throw some debug information in here. Let's have a thread ID. And when we construct our thread, let's increment the thread ID and put that in there so the threads can identify who they are. And so let's change our constructor. So we'll construct with an ID and we'll save that in our ID variable. And then let's just put some print statements inside here. We'll just print a message saying that this thread is working. And let's put an exit message in here. And say we're exiting. All right, I don't know if this is going to work or not. I'm pretty sure I've never written this code before, so this will be exciting. And if it opens a black hole, we'll experience that together. So let's do our imports. So we need sockets. We need scanners. We need print writers. I think that's all we need from here. We need a socket here. And we need a server socket. And I think that's all we need here. I have this sinking feeling when you get yelled at about statics. And this might be okay. Alright, let's give this a try. Hey, not bad. Alright, so our accept needs to be in a try-catch block. Alright, so forever we'll accept a connection, we'll print a message, we'll start a thread, we'll go back and wait for another connection. Not bad. Let's go ahead and run this. Alright, so it's running. And I'm going to use telnet. You can use putty too if you want. Let's talk to port 1234. So got a connection, and I'm going to send the number 25, and I got back the number 5. So thread 1 is doing something. I can send the number 9, and I get back the number 3. There's thread 1 working. I can send the number 2. I get back the square root of 2, and that's working. So let's make another. Another connection. So now it's got another connection, and here I can send 100, and there's thread 2 sent me back a 10. And let's make one more. This can be smaller. So I can send 1,000 and I get back the square root of 1,000, and that's from thread 3. No negative numbers. You're going to open that black hole. Oh yeah, and I could have indented them all. That's cool. And I can come back here and you know, there's thread 1, and there's thread 3, and there's thread 2. And they're all, you know, we've got 3 threads going on inside inside our JVM. All right. So if I close out, let's close out thread 2. And it says thread 2 exiting, right? And that worked because thread 2 was in this, you know, scanner.hasNext double, and since the connection went away, hasNext double returned false, and that kicked it out pretty nicely. So now that's gone, and I could reconnect, and this would be, you know, thread 4. So now thread 4 is running. Alright, so if I throw in a negative number, that should generate an arithmetic exception, or maybe just return not a number. I don't know which. Return not a number, so that's nicely behaved. Awkward. And yeah, you could make a client in Java too. So we'll go ahead and do that. And what if I throw in something that's not a double? I think this will either hang it in infinite loop or it will exit seamlessly. Yep, exited. All right, so that's our basic setup. And all of my telnets, all of my clients have exited, but right, my server is still out there running. It's still listening on port 1234. Right, and these are my clients shutting down, so they're in the final part of that shutdown process for TCP/IP. This is the server that's still in the listen state and is accepting connections. Yeah, I'll publish that. I was going to open a port so you could come in from outside and do that, or I could run this on the Linux machine and you could ping it there. That would be pretty cool. All right, so let's do up the client side. All right. So in this case, instead of accepting a connection, we're going to say construct a socket on the local host at port 1234. And we don't actually need a thread for this one. We can just do this directly. Or we could start a thread, but the only thing this is going to do is establish a connection to the server. So we can just do this here. So we'll make a scanner to read from standard in. And we'll print out that next double. We'll flush the output. And then we'll read the next line from the scanner, which we haven't constructed yet. And so this should loop as long as we have input coming in from standard in. We'll read that double, we'll print it out to the socket, which is the server, and then we'll read a line from the server, which we're going to make a scanner object for, and we'll print that out to standard out. So we'll need to make a scanner and a print writer. Let me see if I can repurpose some code. All right, let's see if this makes sense. We're going to create a socket on the local host port 1234. We're going to construct a scanner to ingest from the socket. We're going to construct a print writer to write to the socket. We're going to make another scanner to read from standard in. We've already got, our default system out that we can use to write to standard out. And then we're going to do a while loop that basically says, while we type in a double, let's send that to the server, and then let's read a line of output from the server and print that out to standard out, and we'll loop here until we hit end of line. And at that point, we'll close the print writer, we'll close the scanner, which might not be a good thing to do, but that's okay. And then that's the end of our main program. Alright, so let's run the server. That's hanging out there running. Let's run our client. So got a connection. We'll send in 25. We get back 5. 56. We get back that. Java client, we can communicate there, and we can get a third one. I typed in something that wasn't a number. So that's sample code. And if I kill the server, then next time I try to send something through here, it's gonna throw up. because I tried to read from a scanner and that connection was closed. So that's an example, right? Basically, we could do this a number of ways. We could construct the server socket. In this case, since we want multiple things to connect to it, we're constructing it, in our main. But for PA5, we could choose to construct it inside, the constructor for the net thread. Or we could construct it, inside the JFrame itself and then pass information to the net thread. Or we could do it inside the run method for the net thread. And, there's different ways you can put this together. The order in which things happen is what's most important. And for PA5, once we have a connection set up, so that's your first task, is get the connection set up. Probably your next task, a good one to work on, is swapping names. So server, we're going to accept, we're only accepting once, right? So we can just do that. The client, we're going to construct a new client pointing to whatever machine the user specifies in port 1234. Make your print writer, make your scanner, make your print writer, make your scanner. And then go ahead and swap your names. And the way I suggest doing this, PW print line my name. And then use your scanner next line to read their name. If you're the client, though, do that in the other order. So read from the scanner to read the server's name, and then on the print writer, print your name, and flush anytime you print to a print writer on a socket. But this makes things a little easier, right? Because the server is going to print right away. The client's going to read before it tries to print. Otherwise, you have the possibility that they're both going to try to read at the same time. If you both print at the same time, you're okay. But if you said scan, read first, and this says read first, you've got a deadlock. So keep that in mind. One question: when you use the designer and then look at the code, it seems sloppy, like everything is in the constructor. Any code that's created by Window Builder, I pretty much leave alone. Because that's sort of boilerplate stuff. That's stuff that's always going to kind of be the same regardless of what you're doing. But the code that you're making, whether it's creating a server socket or starting a thread, just put that at the end. If you're doing it in like the JFrame constructor, just put it at the very end of all of that. Yeah, you're welcome. All right, that's all I got for today. I'm going to sign off. I'll stop recording. I'm going to hang out and talk with one student after class. Otherwise, have a good one. Come by office hours tomorrow if you got issues with this, and we'll go on to something else tomorrow. All right, thanks.